Well then, if you've come for the Daily Space Weather Show, the world's most comprehensive daily space weather content as well as most detailed solar imagery, you've come to the right place. The Smash News Network, least busted name in news. These are 24-hour videos of the closest star, 171 angstroms difference imagery along with 94 angstroms from Solar Dynamics Observatory. You may be interested in a new large sunspot that's recently risen in the northeast. We'll show you some footage of that. The largest solar flare risk remains in the northwest, the upper right side of your screen. There's some fleeting chance of an X-class solar flare up there. M-class events a little bit more likely. Up there in the northeast, which is your upper left, not quite as likely. It looks like an alpha-class sunspot, a prime example of how you can have a really large sunspot, which is really not so good at producing large flares. The size of the sunspot is not necessarily proportional to the likelihood of large flares. It's all about the magnetic field orientation and location. So, again, that's the most likely place to see a large flare in the next 24 hours. By the way, the videos are at 15 frames per second. This evening we usually show 30 frames per second. This was an unrecoverable error. So briefly we'll see what's going on with respect to volcanoes and earthquakes. Looks like a little bit of a lull in volcanic activity. Still an earthquake watch for the west coast of the U.S. Anyway, Ibu, Semeru, Dacono, Popocatépetl, all erupting. Also Nevado del Ruiz, Revenador, and Sabancaya. As far as earthquakes, we have a 7 magnitude earthquake drought. As you can see, a large space between these red bars. That's the past 90 days of earthquake activity. And yeah, like I said, there is a increased likelihood of earthquakes at the western plate boundary of North America. The western North American plate. So we're seeing a number of quakes there, all the way from Alaska, all the way down to central Mexico, south central Mexico. Also in the Gulf of California here by LA. So, plenty of quakes going off there. The possibility that they are foreshocks remains. As far as 5 and greater events, Tonga had a 5.0 early this morning, and then had a 5.3, and then had a 5.6 at extreme depth, over 200 kilometers estimated depth. Then Afghanistan had a 5.0. 40 minutes till noontime, 11:20 Universal Time, is when the Afghani quake happened. And those are the quakes. And before we get to the radio flux and so forth, let's take a look at some more solar imagery. There's another 24-hour video at 15 frames per second. We usually show 30. It's the same period of time, 24 hours, just a little bit more slowly. And let's switch to some stats. The 10.7 centimeter radial flux now at 157 solar flux units. There is the 1-year graph of that. 157 is the new radial flux number. That is in solar flux units, which are, a solar flux unit is 10,000 Jansky of radial flux density. Jansky is a measurement of flux density traveling through space. NOAA's not forecasting any geomagnetic storms, and neither are we, because there aren't any headed Earth's direction at the moment. Earth magnetic moment from space for the past 4 hours. Looking like this, our Geospace Magnetosphere movie. We show it daily on the channel. Things are geomagnetically calm. No, the galaxy is still not going to kill you. These are the past 4 hours of Earth's magnetic moment from ground level, our ground geospace magnetic perturbations map. depicting magnetic flux density at the ground level. Changes to Earth's B field, the B field being the field going through the magnet, this magnet being Earth, otherwise known as Arth in certain fictional depictions of reality. That's the past 4 hours. KP index coming up off of 0, now up to 1. KP1, we do have an elevated solar wind speed, which we'll get to here after we get past the ACE. The ACE is showing very slow and very diffuse solar wind. Meanwhile, the Discover much faster and much denser. So at the Discover, 470 kilometers a second there, at about 3 protons per cubic centimeter. So we also had this strong negative BZ component, but the field wasn't that strong. So the field was only 7 and then 6 nanotesla with that little bit of BZ on that top frame there. That is not enough to produce very much of a geomagnetic anything. It's a KP1, calm conditions. GOES magnetometers here, pretty smooth. Nothing to write home about in the outer Van Allen belts. Next, our ecliptic plane from the top view. Earth now in a South Pole-oriented sector, shown here in red. Expect to remain there for a few days. Here is our line-of-sight field plot, 4 days worth of activity there. The sun's magnetic fields, all in one convenient clip. Coronal hole line-of-sight plot. Coronal holes show us the solar polar field reversal process throughout the solar cycle. Expect coronal holes to continue at this level or higher for the next 16 months. In fact, for the next 16 months, you can expect all solar activity to be around the level that it is, as we're about 8 months from solar maximum. Sunspot number has now dipped down below 100, so sunspot number now at 85. So if you're frightened, let's see, if you're frightened of an inactive sun, now you go into the bunker, and the people who are frightened of an active sun, they can come out of the bunker. Maybe you guys should have a bunker timeshare, right? If you have a bunker timeshare, that might be really cost effective for you. The people that are frightened of an active sun can come out, and the inactive sun people can go in because they're spooked of low sunspot number, and then I'm afraid of the sun when it's active people, they can be out in the world. You know, you see what I'm saying? Yeah. What about that? A bunker timeshare. I think there should be a bunker timeshare for sure, folks. Next, our synoptic map, and there you go. Spencer agrees. You see that sunspot 3583 about to set in the northwest? Most likely place for large solar flares. About a 5% chance of X-class flares according to Spencer. No arguments from me here. Here's our flare probability monitor and scoreboard, and there you go. A big sunspot rose. It's not very exciting. It's not likely to produce large flares. It will be the next numbered sunspot, which will be known as 3591. So yeah, that's a name I suggest for this sunspot right here. 3591. It's really hard to write letters with Epic Pen. All right, let's take a look at some more stuff here. Oh, coronal holes. We haven't gotten to that yet, so there you go. Coronal holes, painstakingly downloaded for you here at the Smash News Network. Least busted name in news. And it's not so exciting for coronal holes at the moment, although there are some South Pole-oriented ones here rotating in. So this area right over here, it's going to become more well-defined in the coming days. It may provide elevated solar wind conditions. Next are sunspot maps. This is the SDO continuum showing the magnetogram there, and things have been stable over the past 24 hours. Let's cut to the raw SDO continuum. Again, we're at 15 frames per second tonight, folks, so the clips are a little bit longer, a little bit slower. Half the speed they normally are. You'll get half the runs you normally see. So next, we'll show energetic particles and flares. So first what happened? Where am I? There I am. So the GOES proton flux here returning to baseline levels. No likely polar radio brownouts or blackouts at the moment. The X-ray profile has been dipping. So Nothing very exciting going on as far as solar flares. It's been pretty quiet for the past 24. And let's get to some more solar imagery. What about some 131 angstroms? That's pretty good, right? There's 131. So we're going to kind of shut down the warning for, or the watch for solar flares in the northeast, which would be your upper left, because that sunspot that rose up there, it's alpha class. It only has one North Pole umbra. I'm pretty sure. I mean, I haven't really looked too closely, but it certainly looks like an alpha class sunspot. So that's what's been going on. And before we get to CMEs, let's look at a star chart. I guess that counts as space weather. Yeah, sure. Why not? So that's what's going on overhead Lehigh Valley, Pennsylvania. If you want to put in your own location, just press the Now button after you've programmed it in. And if you're seeing the early evening sky, you might see Jupiter and a gibbous waxing moon. Solar system forecast is next. That is where things are today. That is where things will be in 1 week. Full moon in 6 days, folks. 6 days until full moon. And check it out. It's our astronomy photo of the day. It's a galaxy that has a large void-like area excavated out of the middle of it. It's what you'd call a ring-type galaxy. And that other ring galaxy you see down there is actually a more distant object, not really involved. Now, the theories as to how this can form have to do with galactic collisions. Of course, ultimately, we're not really entirely sure how that might be, because the infrared spectroscopy indicates that it is unlikely that a galactic collision caused that. So if you have theories, let us know in the comments what you think. Hoag's object. How did it form like that? It's like a weird donut-shaped galaxy with an elliptically shaped galaxy in the middle. One of the theories is that it used to be a barred spiral, where there was a bar like this, and somehow the bar, through its rotations, has like vacuumed up everything in the center. There are a lot of red stars toward the center of this galaxy also, which, you know, some people think indicates something to do with the age of those stars, and I'm not going to get into the way stars evolve or anything like that. That would be going way too far, but an interesting object nonetheless. Hoag's object. Basically like an elliptical type galaxy surrounded by a ring-shaped galaxy with dozens of spiral arms, or possible spiral arms. Next, CMEs. And we've got to show these at full screen size, right? So here we go. CMEs from the past 24. And there may be one with earthly directed components there. In fact, I think there is. It's pretty mild looking. And we are on the wrong day. That is yesterday. Here is today. That's better. So there was one very early this morning that I thought may have an earthly directed component. If so, it'll be very mild, and it'll show up sometime late in the day on the 21st. Besides that, not a lot going on there. Well, there is one decent CME around midday. So let's see if that one's earthly directed. I think the one in the morning might be. I'm not so sure about the midday one, but let's take a look a little bit more closely. What the heck? Well, when was it? Okay, at about 10:30 we saw it coming out. All right. So 10:30, there it is. All right, that one's clearly out of the south-southeast, right? All right, no problem. Let's see what we can find here. And no, I don't think it's earthly directed. I think it's on the far side. But the earlier one was from this filament right here. There was a filament eruption. You'll see right in this area right here, that filament right there does erupt and is likely partially earthbound. So another mild CME likely to show up here sometime after, like late in the day on the 21st. Late in the day on the 21st of February. A minor CME impact is likely. Meanwhile, here are the views from Stereo A. Let me bring these back also. We're going to pause this one after it erupts. And there it goes. That one just likely a light show, but the one before that, right in there, that one, that is earthly directed. So at least part of it. Some will miss to the south. Some will likely hit Earth. So that came from the north central region there, just north of the equator. So likely to be a minor Earth impact there on the 21st. So there you have it. Minor CME impact in the forecast. And let's take it to filaments. Oh, before we do that, how about a brief encore of this awesome series of images? That's 171 angstroms, the 60-minute running difference, superimposed on 94 angstroms. Two different species of ionized iron there. Great at showing magnetic filaments, active regions, and prominences. Anyway, back to our filaments. Filaments are first, and here is Cerro Tololo, Chile. So lots of dense filaments still in the Earth-facing portion of the solar disk. You can see one of these does partially erupt. Right in there. Whoops, part of it blasted off and is headed in our direction. That's always a good thing. And here we've got some prominences happening right now. Oh, a big prominence kicking off once again here. A huge prominence coming out of the North Polar region there, folks. Both in the northeast and the northwest. Check it out. That's going to be a massive CME, folks. That's a lot of material there. And when that much material is moving, that's going to be blasting off. So 100% chance of a coronal mass ejection in the coming hours. So we'll keep streaming it to the Twitch channel like we always do. You can find it at smashomash.com and so forth. So bonus features are next. Let's do it. There are the past 2.5 hours from the Go 16 SUVi. Here are charging hazards for satellites, and we ain't got none. Goes electron flux here, kind of low. Kind of low. There's the 1-year graph of the electron flux from Solon.info. There's the NOAA forecast expecting a dip. I don't know why, but there it is, expecting a huge dip in the electron flux. Next, the layer where it's measured, the F layer. Gotta have it, or you're effed. So there's the F ionosphere. Let's go back to this view. I like this view better. And there you go. That's what's happening at about 300 kilometers of altitude in terms of vibrational frequency. Here's the anomalygram. If that was Greek to you, that's okay. The anomalygram should clear things up. It shows anomaly in megahertz from the 30-day median. Quick reminder to our YouTube viewers that view the videos on a mobile device, you can zoom in 8 times, and we are showing a lot of pixels. So use those to your advantage if you want to look more closely. You can zoom in 8 times using the YouTube app. Next, the WAM, the whole atmosphere model. It's enough to make me want to do a careless whisper into your ear about what's going on with the total electron content, which is once again a little bit anomalous in the North Polar region, it looks like. So we covered it last night. Eugene the philosopher didn't respond, even though we tagged him in 2 clips. Eugene, what's up with that? Last but not least, the latest intensitygram and colorized magnetogram. Again, this sunspot not magnetically complex. Well, maybe it is. Maybe it is. We're hoping it is. Do we have more umbrae rising? And it looks like we do. So that's a good thing. Might be another sunspot group trailing the alpha class group, or it might be part of the alpha class group, likely to make it a beta class group. let's hope it's the second thing, as that makes for better space weather. Anyway, there's the full disk. Whoa, 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 what's happening? There's the full disk rock back. Once again, most likely place for large solar flares is right up there. In the... Oh, wait a minute. You can't see that, can you? No, you can't. No, you can't. So here. There you go. That is the most likely place to see large solar flares. Followed by that. So, but still more likely in the northwest. Anyway, once again, there is the full solar disk. And let's get to meteorology. First thing we're showing is a hellscape. A place in the world. A very specific place with 50-foot seas. Yeah, 50-foot seas. That is not a place to be on any kind of a boat. Look at that, folks. That is not cool. 50-foot seas, folks. Where is it, you're wondering? It's also the windiest place in the world for sustained winds, the South Central Indian Ocean. So that is a place to definitely not be. And especially don't be on a boat with hunks like Marky Mark Wahlberg and George Clooney, because there's nothing worse than seeing hunks drown. Next, surface winds of the east, the jet streams of the east. There's that typhoon in the Indian Ocean, jet streams of the central world, surface winds. Surface winds of the central, of the western world. Lows over both coasts. And let's don't forget the jet streams. Big jet stream convergence happening here in the northwestern Atlantic. The winds up there in the jet stream blowing 233 miles an hour, over 200 knots. That is a major jet stream intensification that will create lower relative pressure on the tail end of that and so on. And I'm not going to get into it any more than to say that and move on to our clouds and fog views. Clouds and fog over the Americas are next, as clouds rapidly form after sunset in Brazil. Shout out to Bruce. And remember, folks, the glory of looking into the void is the realization that there is nobody looking back. There are clouds and fog over the U.S., and it's... Oops, I apologize for that sudden zoom. That sudden scroll, that was not intentional. That was called me fumbling the mouse. I fumbled, but then I recovered. So there you go. Clouds and fog over the U.S. as another storm system here is moving across the Rockies. Next, precipitation type, and we've also drawn in the pressure isobars here to show where the snow and where the rain are as rain sets back into California. So heavy, heavy rain coming once again. Check it out, rain accumulation for the next 3 days. You've got some areas here that are expecting 6 inches of rain plus. 6 inches of rain plus, folks. That's the Euro model. Here's the GFS model. Looking not quite as grim, but not so good. Still 3.5 inches of rain. So heavy rains coming to California, especially both in the GFS model and the Euro model for the next 3 days. Weather.gov's next. Weather.gov. That is where to get your weather warnings. The National Weather Service homepage. And how about some forecasts? 72-hour GFS are the type. That's pressure and precipitation. Look at the heavy rain and snow coming to California especially, and then making its way over the Rockies. Mainly the northern portion of the Rockies, central Rockies, the Rockies. Next, GFS total accumulated precipitation forecast in inches, and you can see there 6 inches on the forecast for California. Suboptimal. Don't be next to a mountain before it collapses. Landslides are not particularly survivable. Next, accumulated snow depth change in inches, 72-hour GFS model, and as we said yesterday, you can see areas here expecting over 2 feet of rain. 2 feet of snow. So the forecast came down a little bit since yesterday, possibly because a foot already fell. So there you go, big time. And remember, folks, it's the year of the dragon. And the most important thing to understand about dragons' lairs is don't try to sneak up on dragons in their own lair. That is a terrible idea. So it's a great year to know this, as it is, like I said, the year of the dragon. Here's our temperature anomaly forecast in degrees Celsius for the GFS 72-hour model. And there's some warm weather about to sweep across the country. Here it comes. It's going to come to the Great Lakes states first, and then move east. Next, our lightning map. That's the last 10 hours, and I think it looks like it's missing some data there, so let's move on to a real-time lightning map, courtesy of lightningmaps.org, powered by blitzachtung.org. And there is some lightning there off the California coast. Some sporadic strikes there. And did you know that water is a poor conductor of electricity, folks? Yeah, water, it's a poor conductor of electricity. People think water is a magical conductor. It's crazy. Anyway, here is our Doppler radar. California and Florida getting plastered with rain. There are clouds and fog. And there is water vapor. So you can see that dry air is going to push that moisture out of Florida pretty rapidly as another atmospheric river makes landfall at California. Here's your recap, U.S. Doppler radar. Clouds and fog and water vapor. When your Doppler's unclear, if you understand atmospheric physics, that map will make it entirely clear. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.